Right, we're carrying on with this hydrocarbon. Right, the table shows percentage composition of mixture of gases in the exhaust fumes of a car. So what they're saying is you had 14% carbon dioxide, you had carbon dioxide, you had 2% carbon monoxide, you've got hydrocarbons, you've got nitrogen oxides, you've got sulfur dioxide, you've got water vapor, and you've got gas Z. Right, so what they're saying is you need to know the composition of air. Right, and this is how I know it. So you've got nitrogen. Okay, let's write it this way actually. 1 second. Is 78%. Oxygen 21%. Nitrogen, oxygen, argon is 0.9%. Right, carbon dioxide is normally given as at 0.04%. And then you've got other things. That's what you need to know. So look, if you look at this, this is gas Z. It'll be 72%. So that's the closest one. So it will be nitrogen. So look, if you can learn this, more so that bit, you're on your way. You can work this one out. So octane, for when they talk about combustion, you're talking about it's related to using oxygen. And you've got to remember that oxygen is a what? It's a what? Diatomic molecule. So it exists, what they're saying is it exists as a pair in the real world out there. So I remember it as no nitrogen, oxygen, hydrogen. And then you've got your group 7 halogens. So I remember that's fluorine, chlorine, bromine, and iodine. These are the ones that we use normally. And remember they come in pairs. So it's good to know all this again. So this is for you to learn. This is for you to learn. There you go. Octane plus oxygen gives carbon dioxide plus, oh, they want a word. Water and water. Right, how is carbon monoxide in the exhaust fumes? Right. What they want you to do, when you've not got enough oxygen, you're going to get carbon monoxide. It's called incomplete combustion. Right, a chemical equation to higher nitrogen dioxide is produced in a car engine. So you've got nitrogen plus oxygen gives nitrogen dioxide. So have you noticed it's not balanced? We've got 2 oxygens, we've got 2 oxygens, we've got 2 nitrogens, we've got 1 nitrogen. So we can't stick a 2 here, that would be wrong. Okay, so we have to stick a 2 here. Now I've got two nitrogens, but I've got 2 times 2 because I've got two oxygens here and I've got two lots of 2. So really I've got 4 oxygens, so I just simply put 2 there because I've got 2 times 2, which is 4. Now that's balanced. State 1 problem, it causes acid rain. It can also cause breathing problems, so for asthmatics. Breathing problems. We call it asthma. Asthma. Not asthma. Right, okay, there you go. We've got 4 hydrocarbons. Give the name of the hydrocarbon W. So remember, monkeys eat peanut butter, meat eat probute. So it's got 3 carbons, 1, 2, 3. So it's got 1, 2, 3. So it'll be propane. Why is it an ane? Because it's got a single carbon to carbon bond. So if you look here, let's get rid of these first. If you look here, you've got 1, 2 single carbon to carbon bonds. So it's a propane. Right. We need to look at the molecular formula for hydrocarbon X. So what you do is you put C down on 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Which hydrocarbon belongs to the same homologous series? So the two that we look at are what? Alkane. It's got one E, so it's got a single carbon to carbon bond. And alkene, it's got two E, so it's got a double carbon to carbon bond. And remember we said each carbon has 1, 2, 3, 4 bonds. In this case, you've got 1, 2, so we've got 3, 4, 3, 4, and we stick a hydrogen at the end of that bond. It bonds with hydrogen. What did we say? We've got to learn this. 2 carbons for hydrogens. It is ethene. And this comes out of your gas tap. It's called methane. Right, 1, 2, right, okay. You notice that this has got a double bond. So that's an alkane. Sorry, I'm lying to you again. Alkene. These 3 are alkanes. W, X, and Y. Give the empirical formula of Z. What it is they want you to cancel it down to its simplest form. So I've got C2H6. I know that 2 and 6 are both in the 2 times table. I can cancel that down to 1. I can cancel that down to 3. So mine is CH3. Remember we said you don't need to write that one. Right. Why is Z? Remember this says Z. It is not Z. No, it is Z. That is United Kingdom. This is our American friends. Right. Unsaturated means it has a double carbon to carbon bond. Hydrocarbon because it only contains hydrogen and carbon atom. Okay, there you go. That's that done. Substitution reaction between W and bromine. Where's bromine? Bromine. Bromine. Did it say bromine? Bromine. Where's W? W. Okay, 3 carbons. So you've got 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So you've got hydrogen all zive around. Right, there you go. That was easy. Right, we're going to add bromine. And we're going to do substitute. So look, what's going to happen is this hydrogen or any hydrogen, we'll just remove, is going to substitute with that. So they're going to swap places. Okay. So what I do is I do this, do this, I do this, I put BR. Okay. Okay. BR. And I put the H there. There you go. That is the displayed formula there. Okay. Right, you need UV light, ultraviolet light. Let's keep going. Butene is a member of the homologous series of alkenes. What is, right, remember what I said, isomer, not isotope. There's an isotope. There's an isomer. Isotope is atoms of the same element that have the same number of protons but and different number of neutrons. Learn this definition. But we're not interested in that, are we? We're not interested in that. We're interested in isomer. So let's go around here. Let's go around here. An isomer is molecule with the same molecular formula but different displayed formula. There you go. Learn these two. They come up a lot. Right, okay. That is what an isomer is. Right, what else can we do here? Draw a structure of butene. Bute tells us it's got let's do this. Monkeys eat peanut butter. Meat eat prop bute. 1 carbon, 2 carbon, 3 carbon, 4 carbon. So we need 4 carbons. 1, 2, 3, 4. But it's an ene. And it's 1, so the double bond is there. Each carbon atom is allowed 4 bonds. So that's like 1, 2, 3, 4. Stick a hydrogen at the end of that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's 1. Okay. Describe a test that would distinguish between butene and cyclobutane. Cyclobutane is this thing here. It's one weird one there. Right. How do you test for an alkene? What did we say? You add what? Orange. You add orange what? Bromine water, and it turns colorless. Right. Using your reaction knowledge of ethene to characterize the reaction between butane and steam. Oh my word. Right, that is a typo. That should be facing that way. So what they've done. Oh, whoa. It's a 3 marker. I forgot this, my fault. I've just seen the mark scheme. Right. And it will remain. Right, if you add on it with colorless with, it turns colorless with but 1ene. It will remain orange with cyclobutane. There you go. This is what it is. Right, we're on. Whoa. Being too hasty. So what we're gonna do is, what we're gonna do is, I'm gonna do this. Right, what you end up with is if you add an alkene to water or steam, it becomes OH. Oh, it's a bit tricky writing it this way. Listen, what I'm gonna do is, there's no what I can do. I need to add OH. Just running out of room here. So what I'm gonna do is I'm gonna add OH. It would have been nicer there, but the double bond is here, so I need to really add it at this end. You can add it there or you can add it here, but it has to touch. So look, they want it to touch the O first. The O bonds with the carbon and the hydrogen bonds with the oxygen, so it's OH. Right. Okay, so the polymerization of butene, we need to. Right, so what they're saying, you've got lots of an n number of these met, eth, prop, but 1ene. Yep, that's again a typo. It should be that way. That should be that way. So what you do is this double bond here, it breaks, right? And one long bond goes that way, one long bond goes that way, and then you just literally copy the rest of the molecule. There you go. Okay, what's next? So you've got now 6 organic compounds. Really, simple way of looking at organic compounds, they contain carbon. Not 100% strictly true, because they've turned around the certain compounds like carbon dioxide that are not organic. Right, which letter represents a compound with its displayed formula? That's the only one that's showing all the bonds. The same member of the homologous series. Remember the word homogeneous, homeostasis, homologous. is equals same. So which are part of the same series, and basically they've got to have either single bonds or double bonds. I can see an alkane there. CnH2n. You've got, that's an alkane as well. That is not an alkane. That is not, that's an alkene. So these are the only two. So it's U and X. Which letter represents compound that is formed from methane with a substitution reaction? So methane is the stuff that comes out of your gas tap. It is a hydrocarbon. It's an alkane. It's got four hydrogens, one carbon. Single carbon to carbon bond as such. There's no double carbon to carbon bond, so it's an alkane. So methane plus by a substitution reaction. Okay, this is what they're trying to say to you. If you react them two, you end up with that, because one of them substitutes with one of them, so you end up with this. That disappears, that disappears, you end up with Br. The hydrogen goes there. Methane. Which letter? V, I suppose. Right. When you burn something in air, it involves what? What does it involve? Oxygen. And it's called, what's it called? Combustion. So you got that plus that gives that plus, now we need to balance it out. 2 oxygens, 2 hydrogens. I've got 1 carbon here. I've got 1 carbon here. I've got 4 hydrogens here. I've got 2 times 2 is 4. Now I've got 4 oxygens here. I've got 2 here. 1 times 2 is 2, so I've got 4. Excellent. 2 is 4 is or 2 of them, 2 of them, and 2 of them. So it's just playing around with these so they all balance. All the carbons and hydrogens and oxygen will balance here, so you need to play around with that. Say white carbon monoxide is formed. Right, when... Oh, not how it's formed. Why is it poisonous? Okay, it's formed because you have... It's something called... Right, we don't need to write this down, but incomplete combustion, where you have not got enough what? Not got enough what? Oxygen. There you go. Right, what else is there? Why the carbon monoxide form? Right, why is it poisonous? Because, right, this is probably the best way. It decreases the capacity of the blood to carry oxygen. There you go. Done. Right. Burning compound X in a car engine can cause environmental problems. You get nitrogen oxides. They react to form an acid. The acid damages some buildings. Name the 2 gases that form. So it's nitrogen and oxygen. Give the formula of the acid. Is HNO3. What is it called? Nitric acid. Right, it's limestone. It can damage limestone and it can damage marble. And it can damage iron or steel bridges. There you go. Right. Let's have a look. Wow, dude. Right, let's keep going. I think we're gonna have to squeeze another one or two so we can make this video and another video. Right, what you need to do, look here. What you need to do here is look at number of protons equals the number of neutrons, which equals the number of electrons. We're interested in that number of protons always equals the number of electrons for atom. Now watch this. If the number of protons and neutrons is not the same, it will be an ion. So these are 5 pluses, these are 5 minuses, that we end up with a +1 ion. +1 ion is called a cation, a Billy ion. And a negative ion is called a anion. Right, okay, there you go. So green, red. Okay, let's do like atom, and that's it. Those are the atoms. Right, explain which two letters represent neutral. Right. Whoa, dude. So what we need to do is write. They have the same number of protons and the same number, oh no, silly, and the same number of, I was going to put neutrons, electrons. For an atom to be an atom, it has to have the same number of protons and the same number of electrons. So it is A and B. Why is it? Because it's the same element. So look at this, right? What makes carbon a carbon? What makes a carbon a carbon? What makes a carbon a carbon? It's the number of protons. The number of protons. The number of protons. There you go. Explain which two letters represent negative ions. Right. If the number of neutrons, if the number of electrons is bigger, number of electrons, right, now they are all negative. They are all negative ions, but which are from the same element. And we said you look at the number of protons, and the number of protons are same there and there, so it will be G and H. Why? Because they contain the same number of protons but have more electrons than protons. So that's where your 3 marks are coming from. Look, watch this. Okay, contain the same number of protons. That makes it the same element. However, it has more electrons than protons. protons, so that's what makes it negative. Yeah. Look, minus if. I read that as negative. That's cool. Let's keep moving on. Let's keep moving on. Let's keep moving. Explain which reactant with the lowest mass. Ooh. Right. Let us get rid of all this. This is all gone. This and all this. What we do is protons and neutrons. Protons and neutrons. So 5 plus 5 is 10. 5 plus 6 is 11. Right. So the lowest one is A. It is A because it has fewest total number of protons and neutrons. What is the electronic configuration of species? Species? Species. E. E by gum. The 7 electrons. 7 electrons there. 7 electrons. 7 electrons. What's going on? Anyway, it doesn't matter. 7 electrons. So there's 2 electrons in the first one and 5 electrons in the seventh. 7. You have 2 electrons in the first shell, and you've got 2, 3, 4, 5, 6, 7. So it's going to be 2 on the first one, dot 5 on the second one. Oh, right. How did we set this out? We said set it out like this, didn't we? We said mg 24. No, we didn't. Stop it. We can do it easy way. What we do, put a fraction line, put that number here, times that number, plus that number here, times 10.1, plus 26 times 11.3, all divided by, if I add up all these percentages, it's normally 100%, because normally it's half 100%. If you add all those together, divide that, you should get 24.3. Yep. Right, let's try to squeeze this one in. Compounds containing double carbon to carbon bonds are used to manufacture ethanol and plastics as polyvinyl chloride. Explain which of these 3 compounds are hydrocarbons. Right, look, that's not got only hydrogen and carbon. So that is not a hydrocarbon. So it'll be A, B, C because, why? Because they only contain hydrogen and carbon atoms. There you go. Don't be lazy and write H, hydrogen and carbon. Write it out fully. Which shows the displayed formula. What would we know right, okay, we know molecular formula, we know the structural formula, we know the displayed formula, and we also know something called that starts with an E, P, M. No, silly. Can't even spell anymore. What's going on? Empirical formula. Right. We need the displayed formula. That's the only one that's showing all the bonds. It shows all the bonds. There you go. Right. Ethanol can be manufactured using that technique, or ethanol can be manufactured using glucose. This uses glucose, this uses ethene. This is advantages of using each. Right. The first one uses ethene. It gives a purer form of alcohol. It is a quick process. It's a quicker process. It doesn't take 2 weeks. Quicker process. It is more efficient. It uses more. It has a greater. They call it atom economy, because anything that's not used is recycled. Come on, got to learn to spell now. Economy. There's no carbon dioxide produced, so no greenhouse gases. Right, with this one, it uses lower lower energy because it is at room temperature, so you don't need energy. It is at lower pressures, so you don't need expensive equipment, and it uses renewable resources. There you go. Right. Right, okay, let's keep going. Right, you've got this reaction. Right, how many carbons have I got? If I want to work out compound C. So compound C reacts with bromine. So there's your bromine. But how many carbons have I got? 1, 2, 3, 4. So I've got 4. So it'll be, right, butene. Right, but what you could do is, can you see there's a bromine on each of the second and third atom? We can call it but2ene. Right. So you've got 1, 2. So this is how it starts off life. Hydrogen, hydrogen, hydrogen. That's a H, by the way. H, H, H. So you got meth, eth, prop. Really, did I just write that? We need one more. I cannot count anymore. This is no good. I must retire. I tell you what, look. Tell you what. Let's grab you. Can we grab you? Can we grab you? Can we grab you? No, we can't. That's no good. Oh, we can grab you. Yeah. Okay. That's my fault. Oh, come on. What's wrong with you? Right. I don't know what's going on. Everything's falling. Yeah. Right, listen. Let's not try to be too clever. You got that. Right, that's what it is. Look, you've got first carbon, second carbon, third carbon, fourth carbon. So it'll be 1, 2. It'll be but2ene. Whoa, am I doing that? But2ene. There you go. State the color of the product form when compound C reacts with bromine. Right. When bromine, it goes colorless. There you go. What is an isomer? What did we say? Molecule with the same molecular formula but different. I like to use the word displayed. You can use the word structural as well. Displayed formula. There you go. Okay, so what we're doing is we've got a compound, a molecule here. We're going to add water to it. That will be called hydration. And because you've added one molecule, another molecule, and you've only got one product, it's called addition. Right, it's called addition. Name, state the polychloro chloroethene. I know it as polyvinyl chloride. Write an equation. Right, okay, so you've got lots of an n number of these, and it gives that. There you go. Right, what we'll do is we'll call it quits there. That's already 42 minutes long. We'll start the next one on the next video.